Hello friends, Yaro Stanchak here. This is a continuation of documentation, Zero Force Motor Video 20.4, 6 poles. A little bit different from the other one with still 6 Neos on it, but they're a bit wider, and wanted to see how this would play out. The gap between the Neos and the coils is about 1/8 of an inch. A little bit too fat for my liking, but it makes it for a conservative running machine. Doesn't give you everything that you're looking for, but useful for experimentation. What I'd like to show today is a couple of things. I do want to focus on the back EMF, and then also to show you how it runs fully loaded, and then doing an acid test of only running on one leg. Let's see how this works out. I'll start it up. Hopefully everything's fine. Really cranks up very nicely. I'm going to zoom in on the screen here. We're a little bit lopsided, but you'll have to deal with that. And I'm going to stop it after releasing one leg here. So basically what you're seeing in front of you is a screenshot, and let's take a closer look at the screenshot here. That one leg. We had the negative leg disabled, and instead of seeing the clear firing pattern here, what we now see is that with the voltage removed, we see the back EMF somewhat modified because of the back EMF circuit, and it's clipped at about 48 volts, just a little bit above that. And in actuality, the operating voltage here is 48 volts. Theoretically, this clipping can be transferred back to a battery for charging purposes or what have you. The back EMF, as you see right here, is a continuous sine curve. You don't see it in this area right here because it's overridden by the imposed voltage from the power supply. And looking at it closely on this side, we see that the firing leg itself really lasts between here and approximately right here. And that the downtime where it's shut off is very close to 10-11 degrees total out of the 60 degrees period. So this was running at 4,000 RPM to start, and on one leg it was running approximately 3,500 RPM. Let's go on to the next little phase here. Restart it. Reconnect. You'll hear it ramp up. Okay. Goes back to 4,000 RPM, about 0.44 amps and 48 volts. Let's put a load onto this puppy. It won't stall. I'll put the other piece on. So you notice that it's really bogged down quite a bit, and the pattern on screen is pretty much extended. In other words, it's widened. We can take a closer look at this momentarily. I just want to make a point here that this particular little leg here is where the amperage decreases back to 0. And that leg on this particular setup, it takes about approximately 400 microseconds. That varies with the load and with the speed. So we're running at about 2,900 RPM, and the acid test I was talking about was to remove one leg to see if we can bog this. Let's give it a shot and see what happens. Woohoo! I'm going to stop this right here for the screenshot momentarily. It's running at about 1950 RPM, and the voltage has jumped up to nearly 52 at 1.1 amps. But you can hear it running still and operating. It's lugging a bit. Let's just stop this. Now we have a much better view of how the motor is reacting, and we can see that the back EMF here is a little bit different. The value on the back EMF right there is approximately 44, 45 volts at the peak. And no power running through, so the current is totally flat. Then we fire it up, the coil gets voltage to it, and the amperage rises. Amperage continues rising at a fairly steady rate. It jumps right up, and then upon shutdown, you can see that right here, that it immediately drops to 0 over a span of about 800 microseconds under load. So hopefully that's kind of clear. I just wanted to document this and to share it with people as to how this machine really operates. It's running at about 46-47% efficiency, overall efficiency, with this particular configuration. So I don't know what else to add, but I'm kind of done with this particular rotor arrangement, and we're going to try some fatter magnets. I know that they're going to give quite a boost. We'll take it from there. Appreciate you watching, and happy spring.